Test review, arithmetic sequences, equations, graphs, and tables. Question 1. The graph below shows the amount of money charged for tickets to a concert. And you can see on the x-axis you have number of tickets, and on the y-axis you have amount charged. Which of the following statements is not, I'm going to circle not true. Let's take a look at answer choice A. The cost for 5 tickets to the concert is $150. So let's find 5 tickets on the x-axis, take it up, and it looks like the point is at, let's see, it's between 120 and 160. So this would be 140. And our point for 5 tickets is between 140 and 160, which makes it 150. So answer choice A is true. B, if Steve attends the concert and takes 6 friends, the cost of the tickets would be $180. So if Steve takes 6 friends, that means 7 people are going, including Steve. And if we carry it up, we can see that the cost is going to be greater than 180. So the correct answer for which statement is not true is B. Number 2. Mr. Blah Blah is thinking about purchasing tickets for his family and friends to go to a Dallas Stars hockey game. And you can see 2 tickets cost $70, 4 tickets cost $130, and so on. Based on the information in the table, which of the following scenarios could be true? So we're looking for true this time. Each ticket costs $35. Well, let's see. If I divide 130 by 4, I know if I divide 70 by 2, I get 35, but let's test to see if we get a cost per ticket of $35 when you divide 130 by 4. 130 divided by 4. $32 and change. So answer choice A cannot be true because when you purchase 4 tickets, the cost goes down from 35 per ticket to 32 per ticket. Let's look at answer choice B. Each ticket costs $10 plus a $30 service fee. So for 2 tickets, it would cost $60 plus a $10 service fee would be $70. If you bought 4 tickets, let's see, 4 times 10 is 40. Plus a $30 service fee. Okay, so it can't be B. Because for 4 tickets, it would cost $40, plus a $30 service fee would be $70, but for 4 tickets on the table, it shows $130. Let's look at answer choice C. Each ticket costs $40, and Mr. Blah Blah has a $10 off coupon. Okay, well, if he spends $80 on 2 tickets, and then subtracts the $10 coupon, it would be $70, but let's test it to see if that still holds true for 4 tickets. So 4 tickets times 40 is 160. No, it can't be C, because that would mean 4 tickets would cost 150. So now we're down to the correct answer choice, which is D. Number 3. You have a circle graph on the right that shows cars sold by color. And the question says, the graph shows the colors of cars a dealership sold in January. The dealership expects to sell a total of 140 cars. If the number of red cars the dealership sold in January is proportional to the number of red cars sold in February, how many red cars should the dealership expect to sell in February? So, proportional means they're going to sell the same amount of cars in February that they sold in January, the same amount of red cars. So how many red cars should the dealership expect to sell in February? Well, let's see what percentage of red cars the dealership sold. 15%. So how do we convert 15% to a number of red cars sold? Well, we can set up a proportion where you have percent over 100 equals part over total. And the total number of cars sold is 140, right? It tells us that in the problem, total of 140 cars in February. So we're going to solve for X. And then to solve this proportion, you're going to use bat and ball, which means draw a baseball bat around the two diagonal numbers and then multiply those and then divide by the ball. Or you can simply take the percentage of red cars sold and multiply it by 140. So 140 times 0.15. Do not forget to convert that percentage to a decimal before you multiply. Now let's multiply. 0.15 times 140. And don't forget to move your decimal 2 places. Why move your decimal 2 places? Well, notice that there's 2 numbers to the right of the decimal in the problem. So that tells us we need to move our decimal 2 places to the left in our answer. So the correct answer would be 21 cars. 21 red cars can be expected to be sold in February. Number 4. The table shows the total number of people who swam at a neighborhood pool the first 4 days that it was open. So Monday, Tuesday, Wednesday, and Thursday are the first 4 days it was open. The pool management schedules one lifeguard for every 40 or fewer swimmers. If the attendance pattern at the pool continues, how many lifeguards should be scheduled for Friday? So let's look at the pattern. From Monday to Tuesday, we're going to subtract these two numbers to get the pattern. So 70 minus 55 is 15. So every day we're adding 15 swimmers. So on Friday, how many total swimmers will there be? Well, we look at the Thursday total and add 15, so you get 115. And it says for every 40 or fewer swimmers, there's one lifeguard. So let's break up. There's 115 swimmers on Friday. So let's see how many groups of 40 we can get out of 115. So I have 40 swimmers would require one lifeguard. Add another 40 swimmers to get 80 swimmers. So we need 2 lifeguards. And add another, well, we're not going to add 40 swimmers. We're going to add 35 swimmers to get to 115. 115 would require 3 lifeguards. So the answer is 3 lifeguards for Friday. Number 5. You have residential electric billing rates, and it shows they measure electricity in kilowatt hours. So you're billed for electricity based on how many kilowatt hours you use in a month. And it shows if you use 1,000 or less kilowatt hours, you're going to use this equation to calculate your cost. And cost is represented with the variable C, and C represents amount charged in dollars. If you use 1,001 to 2,000 kilowatt hours, then you're going to use a different equation to calculate your cost. So it looks like based on the equations, the flat rate fee goes up as you use more electricity in kilowatt hours. So you go from a $30 flat rate fee to $35 to $50, but notice that the price per kilowatt hour goes down. It starts at 5 cents, goes to 4 cents, then goes down to 3 cents. So you're paying more in one respect in terms of the flat fee, but you're paying less for usage as you use more kilowatt hours. So let's take a look at the problem. The Wilson family used 1,650 kilowatt hours of electricity last month. So let's place that into our table. 1,650 would go in this part of the table because it's between 1,001 and 2,000. So now we know that we're going to use this equation to calculate our cost of electricity. What was their electric bill for the month? So N stands for usage per month, and it tells us they used 1,650. So all we're going to do is plug that into the equation. So we have the total cost is 35 plus 0.04 times 1,650. So we need to do a calculation. We need to multiply 1,650 times 0.04. Okay, so I know I'm going to move my decimal 2 places in my answer because I have 2 numbers to the right of the decimal. 4 times 0 is 0. 4 times 5 is 20. 4 times 6 is 24, plus 2 is 26. 4 times 1 is 4, plus the 2 that I carried gives me 6. And now, when I multiply a number by 0, it's just 0. So I don't need to multiply this number by 0. I can just move my decimal 2 places now. So this electric company will charge $66 for usage plus the $35 flat rate fee. So let's add that to get our total answer. 6 plus 5 is 11, carry the 1. 6 plus 1 is 7, plus 3 is 10. So their total bill for this month is $101. Number 6. We have a table, we have our problem, and then we have our graph. So let's read the problem. A tub is being filled with water. The equation G equals 5 times M shows the number of gallons, G, in the tub after M minutes. Use the equation to complete the table. Okay, so we're just going to substitute minutes into the equation. And here's our process. Our process is our equation, so 5 times M. So 5 times 0 is 0. So how many gallons at 0 minutes? There's no water in the tub at 0 minutes. Now we're going to turn on the water and for 1 minute. How many gallons after 1 minute? Well, 5 times 1 is 5 gallons. Substitute 2 in for the variable M, so you get 5 times 2 is 10 gallons. 5 times 3, 15 gallons. 5 times 4, 20 gallons. So now we want to go to the right. We want to look at this graph, and we want to plot those points. So minutes is on the x-axis, and gallons is on the y-axis. So at 0 minutes, there's 0 gallons. So that point goes right at the origin. At 1 minute, there's 5 gallons. So this table is not, I don't like the numbering of this table. It goes from 20 to 40. Let's skip over to 4 minutes. There's 20 gallons. And at 1 minute, there's 5 gallons. We're just going to estimate where these, we know that it's going up, so I'm going to estimate the points will go there. And then when I connect the points, it makes a straight line. This is called a linear equation. Linear means straight line. Okay, number 7. Find the pattern and the algebraic expression that corresponds to the following data. Well, let's look at our sequence of numbers, 3, 9, 15, and 21. What is the pattern? It's going up by 6, right? 9 minus 3 is 6, so it's going up by 6. Let's test the rule. So we know we always put an N next to our pattern. We test the rule by plugging in a position number, and I get, when I plug in position 1, I get 6. Well, I don't want 6 for position 1. I want 3, so I need to subtract 3 from the rule. So our rule is 6N minus 3. Let's test that rule again. Let's see if we get position 2. When I plug in position 2 into the rule, 6 times 2 is 12. 12 minus 3 equals 9. The rule checks out okay. Number 8. What's the pattern? The pattern is decreasing by 2. We always put an N next to the pattern. And when we test the rule, we're going to plug in position 1. When we plug in position 1 into the rule, when we test the rule, I should say, we get -2. But we don't want -2 in position 1. We want 16. So now we need to think of our integers, our negative and positive numbers. So I have -2. I want positive 16. So I need to add 18 to -2 in order to get positive 16. If you're not sure why, they're on team negative and team positive. When they're on different teams, we subtract, and there's my 16. So we need to add 18 to the rule. So the rule is -2n plus 18. Let's test it. Let's plug in position 2 into our new rule. So -2 times position 2 plus 18 should give us 14. So -2 times 2 is -4. -4 plus 18. Let's see, we can plug those in a scoreboard. -4, positive 18. We subtract 18 minus 14. 18 minus 4 is 14, positive 14. And that's the value that we're looking for in position 2. So this rule checks out. So the rule is -2n plus 18. Number 9. Use the graph to make a table and to write an equation. Okay, so let's take a look at this point. X is 0, y is 0. So that's going to be our first value. X is 0, y is 0. X is 1, y is 1. X is 2, y is 2. Can you see the pattern? X is 3, y is 3. X is 4, y is 4. Okay, y is 4, x is 4 at this point. Now let's think of an equation that we can write. Well, what's the pattern? Well, the pattern is 1. It's going up by 1. We always put an n next to the pattern. And let's test the rule by plugging in position 1. When I plug in 1 times 1, I get 1. Well, that's the value that I'm looking for in position 1. So our rule is just 1n, or n. Number 10. Given the rule -3n plus 5, what is the term value for the 10th position? Well, all we're going to do is substitute the 10th position in for n and work out the expression. So -3 times 10 is -30. -30 plus 5 is, let's plug that in a scoreboard. Don't take any shortcuts. -30 plus 5, well, different teams, so we subtract and keep the sign of the team that has the most points in scoreboard. So it's going to be -25 would be our answer for number 10, -25. Number 11. Find the length of the missing side using the Pythagorean theorem. The missing side is our hypotenuse. Our hypotenuse is always opposite the right angle. So we're going to substitute 12 and 9 in for a and b into the theorem. So 12 squared plus 9 squared equals c squared. 12 squared is 144. 9 squared is 81. Let's add them and we get 225. And then take the square root of 225. So taking the square root of c to the second power is the inverse, so the exponent goes away when we take the square root, and the square root of 225 is 15. Well, why is it 15? Well, recall 15 times 15 will equal 225. So square root simply means what number times itself will equal the number inside the square root symbol, number 12. So let's label our sides of the right triangle. So 25 is C because that's opposite the right angle. So that has to be the hypotenuse. 15 is A. And now let's substitute these values into our Pythagorean theorem. So we have A is 15. So 15 squared plus B squared equals 25 squared. 15 squared, well, we know from up here 15 times 15 is 225, so 15 squared is 225, plus b squared equals 25 squared. So 25 squared is the same thing as 25 times 25, and we get 625. So 25 squared is 625. And now when the numbers are on different sides, we subtract them. So we need to subtract 225 from 625, and we get 400. Now we're going to take the square root of 400, which is 20. So B equals 20. 20 times 20 gives me 400. So B is 20. 13. Okay. Is this a right triangle? Well, let's not even use the Pythagorean theorem. Let's calculate the area of, we'll call this square A and square B, and we'll calculate the area of square C. Let's see. Let's count the squares. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is a 6 by 6 square. 6 by 6 is 36. Let's calculate. So the area of square A is 36 units squared. The area of square B, let's count the squares. 1, 2, 3, 4, 5, 6, 7, 8. So this is an 8 by 8 square. So the area has to be 64 units squared. So if this is a right triangle, then 36 plus 64 should equal the area of square C. So 36 plus 64 is 100. So let's see if this is a 10 by 10 square. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is a 10 by 10 square. So this does have an area of 100, and therefore, when the areas of square A and square B add up to the area of square C, it is a right triangle. So yes, this is a right triangle. Number 14. Pythagorean theorem. Do the sides satisfy a squared plus b squared equals c squared? If it does, then yes, it is a right triangle. Tell you what, let's cross off some of these. Let's cross off the bottom three. We'll just do, well, we'll do the top three. So we have, let's see, 3 squared plus 4 squared equals 5 squared. So let's see if that's true. If the left side of the equal sign equals the right side, then yes, it is a right triangle. Well, 3 squared is 9, 4 squared is 16. When you add them, you get 25. 5 squared is 25, so 25 equals 25. So yes, this is a right triangle. What about the next problem? 5 squared plus 12 squared equals 13 squared. 5 squared is 25. 12 squared is 144. And 13 squared is 169. Does that add up to 169? Yes, it does. So yes, this is a right triangle. And lastly, 5 squared plus 6 squared equals 10 squared. Let's see if that adds up to be a right triangle. Well, 5 squared is 25 plus 6 squared is 36 equals 10 squared of 100. Does that add up to 100? No, it does not. So no, that is not a right triangle because the left side does not equal the right side. Number 15. Mr. Soggybottom drew a line and shaded part of the graph. Which list is made up of coordinate pairs representing points in the shaded part of the coordinate plane? So all we're going to do is we're going to look at the answer choices and plot those on the coordinate plane and find the answer choice that has all of its points in the shaded region. Answer choice A, 3, negative 4. I can see that's not going to be. 3, negative 4 is going to be down here. So A won't be a correct answer. What about negative 3, 4? Negative 3, 4 is in the shaded region. 3, 8. 3, 8's in the shaded region. Negative 9, 2. Negative 2. That's in the shaded region. So the correct answer is B. 16. What is the area of the shaded square? Well, the shaded square, you should know by now, is the hypotenuse. And says the drawing below shows three squares joined at their vertices to form a right triangle. Well, we know that the area of this square should, when added to the area of this square, will equal the area of the square that forms the hypotenuse. So let's find the area of the two unshaded squares. Well, we use length times width. So for the smaller square, it's going to be 14 times 14. We get 196 is the area of the smaller square. Now let's find the area of the larger of the square that has a side length of 48 feet. So we do 48 times 48. And we get 2,304 is the area of this square, 2,304. So all that we need to know is the when we add the two areas together, so add 196 to this, that'll give us the area of the shaded square. So 2,500. 2,500. So if I ask you, well, what is the length of one side of the square, you can say 50. How do I know that? Because 50 times 50 will give me 2,500. Number 17. Find the length of AC in the triangle ABC. So we're trying to find the length of AC, which is going to be this part, AC. Well, we know this makes a right angle right here. So we know that 20 has to be the hypotenuse. Well, we need to find the length of this leg first. So to find that leg, we need to use the Pythagorean theorem. So 15 is the hypotenuse. So we're going to use, I'll say 9 centimeters we'll call that B. So A squared plus B squared, which is 9 centimeters, equals C squared. There's my C. So I know that I need to subtract the numbers and then take the square root. So I get 144, and the square root of 144 is 12, so therefore this side has to have a length of 12. So now I can use the formula again to find the length of AC. So let's use the Pythagorean theorem one more time. So we have, we'll call 12b. So we have a squared plus 12 squared equals 20 squared. So 12 squared is 144. 20 squared is 400. I need to subtract and then take the square root. I get 256. So the square root of 256 is 14. So AC has a length of 14, and that's your answer. Number 18. Okay, so we have a picture, and it's a pegboard. And we need to find the area of the smallest square. Well, each peg, from this peg to this peg, counts as 1 unit. So this square has a length of 2 by 2, so that has an area of 4. So the area of the smallest square is 4. What's the area of the medium square? Well, let's count the length of its side. From this peg to this peg is 1, 2, 3. So this is a 3 by 3 square, so it has an area of 9. What's the area of the largest square? Well, again, count the pegs. We have, let's see, what do we got here? Well, we don't need to count the pegs here. So what we need to do is we just need to add the area of the two smaller squares, 9 and 4. So this has an area of 13. What's the length of the shorter leg? Length of longer leg, length of hypotenuse. Okay, so the shorter leg is going to have a length of 2. The longer leg is going to have a length of 3, right? Here, this is 3, this is 2, 3 and 2. So what's the length of the hypotenuse? Well, let's use the Pythagorean theorem. 2 squared plus 3 squared equals c squared, because we're trying to find the length of the hypotenuse. So we get 4 plus 9, which is 13. So let's estimate the square root. So the square root of 13, I know, is between the square root of 9 and the square root of 16. It's a little closer to 16, so we're going to estimate the square root to be about 3.6. 3.6, right? Because the square root of 9 is 3, square root of 16 is 4, the square root of 13 is closer to 16. It's almost right in the middle. So let's move on to number 19. All right, you have a top view of these three-dimensional figures. And what this tells you is that in the back left-hand corner, you should have 4 cubes. So you should have 4 here. In these answer choices, there should be 4. And you see that, I'll shade it for you. So you have, each answer choice has 4 cubes in that column. So we can't eliminate any. Let's look at the next, in the middle left column should have 2 cubes. So here you have 2, so that checks out. 2 here checks out. 2 here checks out. But notice you have 3 here. So that doesn't correspond to our diagram here, so we can eliminate C. What about, let's see, we're looking for 0 cubes in this middle right-hand side. Well, here's a cube right here. I don't want a cube right there, so I can eliminate that. I have 0 cubes in that spot here and 0 cubes in that spot here. So we're down to A and C. Let's look at the difference between A and C. Okay, let's look at the back row. So we want 3 and 3 cubes. So notice you have 4 cubes here and 4 cubes here. We don't want 4 cubes. We want 3 cubes in those columns. So it can't be answer choice D. So we're down to A as the correct answer. Number 20. The solid figure below is built with cubes. Which diagram could represent this figure when viewed from directly above? So we're like in a helicopter looking down. So we should have 1, 2, 3, 4 cubes across, just like here. 1, 2, 3, 4 cubes across. And then coming out of cube 2, there's another cube. So we'll call this 2A and 4A, which are the 2A and 4A right here. So the correct answer is C. Number 21, Scrappy Doo was trying to figure out which of these solids was the best match for the left, front, and top views. Let's see, looking from the top down, notice that they've twisted the answer choices. So we need to twist the answer choices. So we're looking from the top down, we're looking for a single long cube, and then 3, looks like 3 separate cubes. So look at answer choice A. So we have the long cube here, and then we have the 3 separate cubes to the right. What about looking from the front, looking in this direction from the front? Okay, it looks like it matches the front. Answer choice A matches this front. And then looking from the left, which would be here, looking in this direction here, looks like it is it's not a match. Answer choice A is not a match, because looking from the left, you should have 1 solid cube right here. So it looks like the correct answer is going to be C. C, because of this section right here. See, this section right here, looking from the left, you have 2 cubes here, and then you have 1 single tall cube here. So the correct answer is C. Number 22. Which expression can be used to find the value of the term in the nth position? So there's different ways to answer this. You can substitute 1 into the answer choices to see if you get 0.5. 0.5 is equal to 1/2. And when you do that, you can eliminate C and D, because 3 times 1 is 3/2, not 1/2, and then 3 times 1 in answer choice D is 3/4. Let's plug in position 2 into the answer choices. Let's see, 2 divided by 2 is 1. We don't want 1. We want 0.75, which is equivalent to 3/4, so the correct answer is B. And the final two problems, number 23. The graph below shows the growth rate of a human fingernail. Gross, I know. Based on the information in the graph, which best represents the number of millimeters a fingernail grows in 25 days. So we have days, and notice on the x-axis weeks. So we need to do a conversion, days to weeks or weeks to days. So let's convert 25 days to weeks. That's about, let's see, divide 25 by, there's 7 days in a week. So it is roughly 3.5 weeks. So right here. So let's draw that line up. That's 3.5 weeks. Let's put a point and draw it across. What's that measurement? Well, that is between 3 and 4, so that's about 3.5 millimeters. So the closest answer choice to 3.5 millimeters is answer choice B. And lastly, number 24. The graph of line y equals 2x plus 3 is drawn on the coordinate grid below. Which table of ordered pairs contains only points on this line? So we need to plot these answer choices onto this graph. So -2, 1. -2, 1 is right here. That point is not on the line, so table A cannot correspond to that line in the graph. Let's see, -2, -1. -2, -1. Okay, that one works good. So that's a check. 0, 3. 0, 1, 2, 3. That's a check. That's on the line. 1, 5. That's a check. 2, 7. That's also on the line. So the correct answer is B.